Are you familiar with RGB, Chris?
Just very lightly, so I'm hoping to learn a little bit.
Yeah, I think it's been a really interesting project focused on client-side validation. I've heard it said that RGB can do anything except send Bitcoin. So maybe Federico can teach us more. So please welcome Federico Tenga.
Welcome.
All right, let's wait for the slide 1 second, hopefully. But yeah, anyway, yeah, I'm Federico Tenga. I work for Bitfinex. In Bitfinex, we have a team that is working full-time on RGB development. Our goal is just to make the RGB ecosystem develop and grow as much as possible. So we're doing this by building mostly a lot of open source tools and writing a lot of open source code. For example, like in the past almost 2 years that we've been working on this project, we developed libraries for wallet developers. We developed like a Latin node and a wallet that we're gonna talk about today, and then we will also talk about the decentralized exchange features that are offered. So, yeah, are the slides coming, or should I just go? Okay. So yeah, I will start giving maybe a little bit of introduction about RGB for those that are not already familiar with it. So RGB is a protocol. It's a, let's call it layer 2 protocol on top of Bitcoin, even if all these layer 2, layer 3 can easily become a bit confusing. So just let's call it upper layer on top of Bitcoin, which allows to have asset tokenization directly on Bitcoin without any security trade-off. So basically it allows people to have the exact same security that you have on Bitcoin when you have a transaction and when you are expecting transaction finality. And this is like as opposed as other alternatives that use either like side chains or altcoins, so that they involve some security trade-offs. But yeah, we got the slides, so let's go straight into the presentation. So actually, yeah, the focus of the talk today is not going to be RGB in general. I mean, we will also talk a bit about RGB in general and give an overview of how it works. But the cool stuff that we want to talk about today is how we can build decentralized exchanges on Lightning using RGB. Before we can get there, we will have to. Oh yeah, if you can just scroll the slide, it should be good enough. No? Okay, well, anyway. But yeah, first of all, yeah, what is the problem we are trying to solve? So there is clearly demand for peer-to-peer payments and decentralized trading with stablecoin and other kind of derivatives on other assets. And there is this demand, but currently is mostly captured by altcoins. So there is a lot of, most of stablecoin payments are happening either on Tron or to a lesser degree on Ethereum. Most of the centralized trading is happening on liquidity pools on Ethereum or other EVM chains. So, and they have big volumes. So there is clearly a market demand, but currently Bitcoin has failed to capture it. And there have been other protocols that we're trying to build to offer tokenization of Bitcoins, but for various reasons they haven't been as successful, also because they failed to fully leverage all the potential of Bitcoin. Because maybe they were too old, like they came too early, like OmniLayer and Counterparty, they've been around since 2013, but they were designed in a period where there was little attention for on-chain privacy, because everybody thought Bitcoin was perfectly anonymous as it is. There was little attention to on-chain space optimization, because at the time blocks were empty. So they were designed in a way that they weren't really leveraging everything that Bitcoin has to offer, also because many of the Bitcoin innovations, such as the Lightning Network, came later. So what are the desired features for a decentralized asset transfer protocol? First of all, we want it to be sustainable to use with consumer-grade hardware. So we don't want it to be incredibly expensive to run a node using to transfer assets. So for example, like in the case of Counterparty, which was this older protocol for tokens on top of Bitcoin, to run a Counterparty node, it will be quite resource intensive on top of the Bitcoin node. So if you wanted to use it on a mobile, on a web wallet, you will have to rely to some degrees to a third-party service. And the same is like with if you want to do stuff with Ethereum and Tron. I mean, it's not really sustainable to run it on a cheap hardware. But yeah, if we want to build something that is truly decentralized, it needs to be able to run on cheap hardware. Then you need to be efficient in the usage of the on-chain space, because yeah, on-chain space is scarce. On-chain space can be very expensive when there is market demand, and we can only expect to become more and more expensive in the future. So we want to use it because it's the only way to leverage Bitcoin security, but we want to use it as little as possible so that we don't need to first spend too much money on fees and then to fill the blockchain with more data than is necessary. Then, of course, we want it to be compatible with the Lightning Network, or in general, I would say with scalability solution on Bitcoins. Currently, the Lightning Network is the only true scalability solution on Bitcoin that is it works in production with real money, and it doesn't involve any trust compromise, trust trade-off, and requirement to trust a federation or stuff like that. And yeah, so if we want this thing not only to be secure, but also scalable, compatibility with Lightning Network and any other future scalability solution Bitcoin is absolutely mandatory. And then, yeah, it would be nice to have some programmability so we can add extra spending condition to the transaction so that we can have more advanced features. And this is the solution provided by RGB is leverage the concept of client-side validation, where basically, as opposed to normal blockchains, with client-side validation, the information of a transaction, they are not published on a public ledger, on a blockchain, but they only shared between the peers, between the parties involved in a transaction. So when I send you a payment, I will also send you I will send you directly to you the information related to the payment, and I will not publish it on a public network of people that are not even interested about the payments, or like they shouldn't be interested about the existence of the payment. So we still use the blockchain, but we only use it for protection from double spending, not as a data availability layer. So we only use the blockchain with publishing the minimum amount of data necessary to fully leverage the double spending protection that we have with Bitcoin transactions. So how do we do this? Each RGB transfer is committed inside a Bitcoin transaction, and in this way we can get all the security guarantees of that Bitcoin transaction. And committed, to make it simple, let's say that we add, it's actually a bit more complicated than that, but to simplify, we add like an hash of the RGB transfer inside the Bitcoin transaction, so that if you want to double spend the RGB transfer, you will have to double spend also the Bitcoin transaction. And yeah, the Bitcoin transaction, we can assume that it cannot be double spent if a sufficient amount of confirmation has been reached. So yeah, this is the general idea of difference between global ledger and client-side validation. With global ledger, all the data is shared with everyone in the network, like in a sort of blockchain layer in case of blockchain systems. While with client-side validation, the data is shared only between the people, the wallets that are interested in that specific transaction, that specific event. So let's look a little bit deeper how RGB transfer works. This is going to be the only, let's say, technical slide of all the presentation. I mean, but the most technical at least. But yeah, gonna try to give you a better understanding of how RGB actually works. So first of all, when you want to issue an asset on top of RGB, there's gonna be an issuance contract that is not a blockchain event. It's just, let's say, a message where we define the information about the asset, the metadata, such as, I don't know, the name, the ticker, the total supply. Then there will be like the validation rules that apply to the transfer of this asset, and yeah, all the information related to the asset. And very importantly, who is the first owner of the asset? How do we define ownership in RGB? The owner of an asset is always a Bitcoin UTXO, an output of a Bitcoin transaction. And whoever is able to spend that UTXO has the right to move the asset. So behind the UTXO, there can be any kind of Bitcoin script. It can be a simple public key. It can be like a multisig, or it can be a very complex taproot output with all sorts of complicated spending condition, or like, I don't know, even like a BitVM taproot output. It could be any kind of stuff. We don't care. We only care, are you able to spend this UTXO or you aren't? If you are able to spend this UTXO, it means that you are the legitimate owner of the assets that were allocated to such UTXO. So in the issuance contract, we define the first UTXO that is going to be the first owner of the total supply. So in this case, let's call it UTXO A. And when we want to do an ownership transfer, we will create a new message where we say, OK, those assets that were allocated to UTXO A, from now on, we will move like out of 100 to add 20 of them to UTXO B and 80 of them to UTXO C. And likely it's going to be that 20 is the amount that we're sending to the counterparty, while 80 is the change that you send back to yourself. And you always need to spend everything that you have, because UTXO, you can spend it only once. It's unspent transaction output. Once you spend it, it's not unspent anymore. So you can spend it only once. So you need to move everything that you have on the UTXO out of it, and whatever you don't want to pay to your counterparty, you send it back to yourself as change, just like it happens with Bitcoin, actually. So yeah, nothing different. And this whole ownership transfer, then it is committed inside a Bitcoin transaction for double spending protection. But not in any Bitcoin transaction. It needs to be committed inside a Bitcoin transaction that is spending the UTXO A. So in this way, we prove that whoever decided that they want to send 20 Bitcoin, 20 tokens to B and 80 to C, is the legitimate owner of those assets, because by spending UTXO A, is proving that he is the legitimate owner of whatever was allocated to UTXO A. And by committing the ownership transfer inside such Bitcoin transaction, it guarantees that he cannot do it twice. He cannot create another version of this message where he sends, like, let's say, 100 back to himself or to a friend of him. Because like the commitment structure is made in such a way that there can be only one valid commitment per Bitcoin transaction. So it's impossible to create double commitments and therefore double spending. And then, once now we have some token UTXO B, and the owner of UTXO B will do the same. We'll create a message when he wants to spend them. We'll create a message that say, OK, out of those 20 tokens that I had, 14 goes to D, 6 go to E. And all of this is committed inside the Bitcoin transaction spending UTXO B, so that he can prove that he's the legitimate owner of those assets, and so on and so forth. But yeah, now let's move towards the more interesting part. So right now we described how it works on chain. So RGB starts on chain, but then it can be moved to upper layers, and they can work with the Lightning Network. So how do we achieve Lightning Network compatibility on RGB? It is possible to modify an existing Lightning node to support RGB assets. And what needs to be done, like a Lightning node can be modified to provide some extra modularity, so that you have more control on the outputs of the Lightning node commitment transactions. And you can add RGB logic on top of that. And once you do that, you can create asset-denominated Lightning channels. So you can have a Lightning channel that, instead of being denominated in Bitcoin, like we usually have, it can be denominated in like a USDT or whatever other asset you may have on RGB. And once you have that, then you can make Lightning payments and do routing with RGB assets with the same speed and same convenience that you have with Bitcoin on Lightning, and also with the same, let's say, trade-offs. So yeah, you still need to be always online. You still need to manage liquidity, and you still have all the little inconveniences of Lightning, but you have also the same benefits. So you can have pretty much the same experience, the same payment experience that you have with Bitcoin on Lightning, you can have with RGB assets on top of Lightning. And yeah, this requires liquidity to work. So if you want to do routing of an RGB asset on top of Lightning, you will have to have a bunch of channels that have liquidity in such asset. So you will probably work with assets that are quite popular, like it can be with USDT or maybe other stablecoins or other stuff that has a significant adoption. With assets that are less popular, maybe it can still work, but it will be a bit more centralized Lightning network, maybe with just a couple of big nodes that everybody connects to, because there is not enough adoption to have a very large graph of the network with a lot of nodes. But still, it's for stablecoin and other popular assets, it can work as good as it works with Bitcoin. And all of this already exists. We developed this year the first Lightning node that supports RGB assets. You can check it on our GitHub, RGB Tools, RGB Lightning node. And we built this in the Bitfinex team. This was a project fully done by the Bitfinex team. We built this using LDK. So we took LDK, we made a small fork adding a little bit of modularity, and hopefully eventually that fork can be merged into the main LDK project, because it doesn't add any RGB logic, it just adds modularity. And then with that, we build a Lightning node that has all the RGB logic inside of it to support RGB asset denominated Lightning channels. But then, yeah, finally to the topic of the presentation. Once we have assets, multiple assets on top of Lightning, then it means that we can also have decentralized trading experience directly on top of Lightning. How would that work? First of all, the idea is that if we have channels that are denominated in different assets, we can create some payments that start with one asset and ends with the other. So let's say that the first leg of the payment is in Bitcoin, the second leg is in USDT. And if this payment is circular, then it becomes like a swap between Bitcoin and USDT. And the atomicity of the swap is guaranteed by the fact that both legs of the payment, they use the same HTLC, the same secret for the Lightning payments. And what are the benefits of all of this? First of all, we don't have to pay on-chain fees, as opposed as we do with decentralized trading on Ethereum, on other EVM chains. So it can be much cheaper. We have low latency, as low as it can be with Lightning. So of course, it depends if you have a direct channel with the counterparty or if you need to do a bit of routing. But potentially it can be less than 1 second latency if you have a direct channel with their counterparty. You have privacy. So no one sees that the trade is even happening if not the two parties involved, which means that there is miners and the Flash bot cannot front run you. So when you do trading on Ethereum with the liquidity pools and the automated market makers on Ethereum, you have this problem that you send to the main pool your proposed trade that calls the DEX smart contract. Everybody can see it, so if it's a big trade, people can front run you, creating a transaction that pays more fee and will go before you in the block, or miner themselves can do that even more easily. So it's quite inefficient to do trading on the centralized exchanging on Ethereum because of this. So you only do it if you are desperate that you have no alternatives. But with Lightning, it can be quite good because there is no problem of front running, and you can have very low cost, and you can have certainty on the price. when you basically on automated market makers on EVM chains, you can only make market orders, and you don't know at which price the trade will actually be executed. While with atomic swaps on Lightning, you can agree on the price beforehand with your counterparty, and then you know that that is going to be the price at which the trade will be executed. So it's going to be a much better trading experience, still completely decentralized, no need to trust anyone because all of this is based on atomic swap, and it's going to be much closer to the experience that you have currently with a centralized exchange. Of course, like not as efficient, not as fast, but still quite competitive compared to what we currently have with the decentralized exchanges on Ethereum, and this can produce a much better trading experience and something that is going to be more useful and more accessible to more people. So how does the swap mechanism work? So first of all, you have the taker. The task is a model based on market makers and takers. So you'll have the taker, the task for the maker for a quotation. Say, okay, I want to buy Bitcoin for USDT. How much do you price it? So the maker will offer a quotation. Let's say, I don't know, $35,000, whatever. And he shares this information through a string that encodes also all the other conditions associated to the swap. So, for example, there is a price, there is an expiration, there is a maximum amount, and stuff like that. Then, if the taker agrees, he will whitelist inside his node that the condition for the swap. So we'll say, okay, if I receive a request to route our payments, that on one side I receive 1 Bitcoin and the other side I need to send 35,000 USDT, please proceed with the routing and accept it. At this point, then the taker tells the maker that is ready to make the swap, and the maker initiates the swap. And when the maker initiates the swaps, he basically coordinates with people in the network to create a Lightning payments that is a one Lightning payments with one HTLC secret that on the first path going from the maker to the taker, it will be denominated in Bitcoin, and on the way back, it will be denominated in USDT or whatever asset they are exchanging. And so like this requires that both the maker and the taker, they have at least one channel in Bitcoin and one channel in the other asset, or like in two other assets also. It doesn't need to be against Bitcoin. It can be between two RGB assets. And, but yeah, and they need to find people that can have liquidity in the asset to do routing. But the interesting thing is that, first of all the people that are doing routing, they have no idea that a swap is even happening. So those guys, they only think they are routing a Bitcoin payments, and this lady only thinks that she's routing a USDT payments. They have no idea that a swap is happening. Yeah, all of this is atomic, so there is no need to trust each other. And yeah, it works. It can be like as fast as a normal Lightning payments. And if you think about it, actually, this is nothing special, because even when we do normal routing on Lightning, at the end, it's kind of as we are always doing a swap, because the Bitcoin that we have on one channel, they are not the same Bitcoin that we have on another channel. They are fungible with each other because we consider them to have the same market value, but they're actually different Bitcoins. So every time we do routing, we're actually operating a swap. So here, the only difference is that we are doing routing, but between assets that have different market value, and we consider them not fungible with each other. But technically, at the end, what happens is not much different than what happens when we do normal routing on top of Bitcoin. So one problem that always is present when we want to do some sort of decentralized trading is the so-called free American call option problem. So first of all, what is the problem about? So a call option in a financial market is the right to buy an asset at a given price at some point in the future. So for example, I can agree with someone that I have the right to buy 1 Bitcoin at $40,000 at the end of the year, on the 31st of December. And this right has a value, because if Bitcoin goes up to 50K, let's say, then that right to buy Bitcoin at 40K is it's very valuable. It's worth $10,000. This right may end up expiring, that is worthless. So let's say that at the end of the year, Bitcoin is 30K. So the right to buy at 40K is not particularly interesting. But there is this possibility that will become very valuable, this call option. So he has a price. And the problem is that when you do decentralized trading, there is always going to be one of the two parties that can do the final trigger to make the swap happen or fail. And this party can hold the swap for some times, and while he's holding the possibility to do the swap, he can see what's happening with the Bitcoin price, and say, okay, do I want to execute, or maybe I don't want to execute because the price went against me. So he has this free option to either execute or not execute at some point in the future. But it's impossible to completely eliminate it without introducing third parties coordinators, but it can be mitigated. So first of all, being on Lightning, we already eliminate the problem that people can double spend the inputs. While if you do swaps on chain, there is the problem that people can do double spending on the inputs. With Lightning, you don't have this problem because the inputs are already confirmed. So this is a first mitigation. And thanks to this, we have only one of the two parties that has the free option. So the possibility, the guy that needs to release the pre-image of the payment. And the option is only valid until the time lock of the HTLC expires. So it's not very long expiration, so it's not going to be so valuable. If it's going to be like 1 hour option, I mean, it's okay. It's not going to be terribly valuable, so there is little incentives to leverage it. And so the idea is to mitigate the problem, we just give the free option to the party that has some reputation at stake, so that he doesn't have an incentive to use it. And in our case, we are giving the option to the market maker, because it's a kind of a service provider. So if he starts misbehaving and always like holding the secret to leverage the option, if he does it too often, people will just stop using his services and will go to other market makers. So it's not a perfect solution, but perfect solution is impossible unless you introduce third-party coordinators, but then you just move the problem to the coordinators. And I think like this solution is good enough and you make the incentive as small as possible, and you give it to the party with a little bit of reputation at stake so that he hopefully doesn't use it. So is all of this good for Bitcoin? I think in general it's going to be great for Lightning Network because it can bring a lot of volumes to Lightning Network that currently don't exist. People are much more interested in trading than in payments. So if we can have more volume on the Lightning Network, it's good for the node operator, it's good for the LSP, it's good for the wallet, it's good for all the Lightning companies that needs revenue. So I think overall it can have positive effects on the Bitcoin ecosystem overall. So yeah, I'm running out of time, but yeah, I already talked a bit about what we're doing with the RGB team before I started the presentation. But yeah, most of all, like you can go to our GitHub, RGB tools, and you find all the stuff that we built over the years, including our, if you want to play with RGB, we have an Android wallet. It's only on chain for now, but you can play around with it. Yeah, this is the end of the presentation, so thank you. Do we have time for questions?
Yeah, go ahead. Why don't we have a question? Just one.
Thank you. I think this is amazing. One question, is anybody already working on prototyping the way to aggregate liquidity among different market makers, because there's going to be many and there needs to be a single point of access for a regular user to swap their assets?
So now the way we're building is that you're going to have some user interfaces that have already some like default market makers, like a few of them, and then you can manually add more of them if you want. But yeah, then of course on top of that you can build some sort of aggregator and create kind of an order book. Yeah, that is like more an upper layer. Now we are focusing more of solving the problem of settlement. Then price discovery, I think it can be solved in many different ways, and it can be like some decentralized layer, like on top of Tor or Kit or on a Telegram chat or a website. So there are many ways to solve price discovery, and we will start just with some default market makers in the first UIs that will be available, and then people can come out with other more fancy solutions. Potentially, yeah, you can also do equity. I mean, we are just building the technology. So we will start with stablecoin, which is where there is more demand right now. If people then want to I mean, there is also interest for security tokens, but security token itself is a market that still need to develop. So I don't know how much demand there will actually be for that. So I expected that most of the demand will be for stablecoin at the beginning. And then people can do whatever they want. That they can make shit coins, equity, whatever they want.
Okay, thank you very much for the presentation and answering some questions, Federico.
Thank you.